In this video, we're going to go through the car mileage example for how to analyze in a subsample design in JMP. I'm also going to talk about the incorrect way on how to do the analysis, and then I'll also show you the average in this balance case and how the F statistics match. So again, recall that in our car example, we are trying to compare and see if there's a difference between these 5 brands. We have 3 subsamples per each car and brand. So let's talk about the incorrect way to analyze this. And the first incorrect way is if we came to JMP, we go to Analyze, Fit Model. We put mileage in your Y and brand, and just add brand, and we click Run. What this analysis is doing is we're pretty much telling R that we have 30 experimental units. So if we look back at our data, it's saying this is 1 experimental unit, this is 1 experimental unit, this is 1 experimental unit. And so it's treating it almost as 3 different cars here rather than 1 car with 3 subsamples. And so this is going to be incorrect, and this analysis does not match with our design. Okay? And so this F ratio, F stat is incorrect. The correct way to go about it is we're here again. We're going to go to Analyze, Fit Model. We're going to put our mileage in our Y. We're going to put our brand here. Now what we're going to do is we're going to add our car, but our car, so whether it's car 1 or 2, is going to be nested in brand. So we're going to click on car, click on brand. Notice they're both highlighted. We're going to click nest. Now we also need to make this a random variable. So we're going to go down here to attributes and we're going to click random effect. Okay, let me repeat that one more time. I'm going to delete this. We're going to add car. Then we're going to highlight car in the model effects. We're going to highlight brand over here. We're going to click nested. Then we're going to come to attributes, random effect. Now we're going to come up here to methods and we're going to go to EMS. This will relate back to our notes where we did the expected mean squared. And then also click on emphasis, go effects leverage. And then you can click run. And you're going to get this output. Here we'll see our ANOVA table. But this F value right here is incorrect. You do not want to look at this F ratio. Don't look at that one. What you want to do is you want to scroll down here and look at the tests with random effects. So this is incorporating that subsample. And you want to come down here and look at the F test statistic related to our brand, which is our treatment. And so we have an F ratio of 24.48. We can also, since you guys are JMP, it outputs your variance component estimates. So here was our sigma squared epsilon, the variance due to the experimental error. And then here is the variance due to the observation. So sigma squared eta. Now, for tests, I want you guys to be able to use the formulas provided in the lesson and be able to get these values from here as a heads up. Now, if we wanted to, so that's how we would analyze it for subsamples. If we wanted to analyze it using average, we can come up here to tables, summary, mileage, we want the mean. We can highlight brand and car, group it, okay. So we're going to get this new data table. Now, since we averaged all the results, which is allowed because we are not missing any data. We can come up here to Analyze, Fit Model, our mean, and then it's just going to be brand because we averaged out those subsamples. Now we're going to analyze it as a CRD, and we're going to click Run. And we can scroll down here and we can see that our F ratio is the same as we had just seen it in the subsample design. Again, in a balanced case such as this car problem, doing a CRD analysis on the averages will produce the same result of is the treatment effective or not as the subsample design analysis. Where the subsample design analysis comes in handy is if you're trying to estimate those two different sources of variability.